So in this video, we will cover the interoperability between 802.11 networks and 802.3 networks. We will talk about interoperability. Okay, so we all understand that we have something called an IS, that is integration service, that converts 802.3 networks to 802.11 networks and vice versa, dot 11 networks into dot 3 networks for wired and wireless to understand each other. That's the basic job of an IS, right? Now there are two major differences between how things work in dot 11 and how things work in dot 3. Okay, first and the foremost is we understand that the size of the frame in 802.11, the MSTU can go up to 2304 bytes, right? And similarly in 802.3, it can go all the way up to 1518 bytes with the payload of course 1500 bytes. Okay, so and if you add in dot 1 q tag VLANs, dot 1 q for VLANs, the maximum size can go all the way up to 1522 with the payload of 1504 bytes. Okay, now this is a problem because if the if the AP receives the frame of size 1500, and or let's say if the AP receives the frame size of 2304, it has to send it on the LAN or 2304 bytes. It needs to send that to LAN on 1500 bytes, so it's going to be a problem. It's not going to work out like that, right? So thanks to TCP/IP suite, because of TCP/IP, we define the MTU size, that is maximum transmission unit, as 1500 bytes for both the mediums. Now this is not a problem anymore thanks to TCP. So we talk on 1500 bytes now, whether it's wireless and wired, and it takes care of this particular problem that we usually can face if TCP/IP was not acting. That is the first difference. Now the second difference, this is the first difference, yes, MSTU size, that's the payload size. Now the second difference, let me see, okay, the second difference is that the MAC address fields in the MAC header in the 802.3 frame, we have a source address and a destination address. When it comes to MAC header and the MAC address fields, we have two addresses to take care of in the frame MAC header, right? But in 802.11, this changes to 4 MAC addresses, not 2 but 4 MAC addresses. So the source address and the destination address will remain pretty much the same as in the wired side, but we have 2 extra MAC addresses, which is called a receiver address and a transmitter address. When one access point is, or when we have a single BSS, that is when we take care of, that is when we have usually 3 MAC address fields filled. But when we talk to different distribution systems, we have all the 4 MAC addresses filled. So the second difference is that the MAC header is the MAC addresses field in a MAC header are more in .11 frame than in .3. And how this is used, I'll take this as an example in the next page. Let me bring up a new page for you. Okay, this again seems to be some sort of a glitch with the software. Let me try and erase it and see if it happens. It doesn't. Okay, so we will go back to the old page, and now it works. Cool. So how this works is, I'll take an example. Now I have a client, this is an access point. I have a client A. This wants to send traffic to the client B out here. This is client A, this is client B, and this has a MAC address, or let's do this. This is client number 1, and the other one is, we'll name it as client number 2. This is an access point. This is an access point. This has MAC address A. This has MAC address B. This has MAC address C, and this has MAC address D. Now, considering the 4 MAC addresses field in a MAC header, source address, destination address, transmitter address, and receiver address, for example. Now these 4 fields we are going to fill. Now this frame, so client number A wants to send a frame to client number B, or I'm sorry, client number 1 wants to send the frame to client number 2. This is the transmission happening. Now how it will happen is the frame will be sent from client number 1 to APC, and then APC will communicate with APD, and APD will send the frame to client number 2. This is more like a wireless distribution system, like we are connecting 2 wireless networks together. Okay, so let's do this. When the frame is with the client number 1, that's how the MAC header will look like. The source and the destination will pretty much remain the same. Source of the frame is A, destination of the frame will be B, A and B, that's it, right? Now the transmitter address here in this scenario is A, because A will be transmitting. The receiver address is not B, the receiver address is the next hop, that is C, where it is going to hit. Now the frame has reached the AP now. Again, the source and the destination address will still remain A and B, because that's how it's in the wired side as well. The transmitter address in this scenario, when the frame is here at the AP, is C, and the receiver address will become D in this scenario, because it will go to D. When the frame reaches D, the source and the destination will remain A and B. The transmitter in this case is D, and the receiver will be B, because this is where the network is going, right? The frame is going. So that's how the 4 MAC addresses fields are utilized. That's what a transmitter address and a receiver address is. You know, if we have only 1 access point, then we only have 3 addresses fields filled. The 4th one is not filled. So these are the 2 major differences when we talk about how .11 and .3 networks differ. One is the frame size, of course, but thanks to TCP/IP suite, this is taken care of to 1500 bytes. And the other one is the MAC addresses, MAC address fields in the MAC header. .3 802.3 has 2 fields, but the 802.11 MAC header has 4 fields. Okay, cool. So this is what I wanted to tell you in this video. In the next video we'll talk about different types of .11 frames. That's the management frames, control frames, and data frames, and we'll take some examples of that as well. So see you in the next video. Thank you.